physical properties of carbon monoxide are, it is a colorless, odorless, neutral, gaseous oxide which is highly poisonous. Photosynthesis dominates during the warmer part of the year and respiration dominates during the colder part of the year. This photosynthesis and the respiration will play an important role in the carbon cycle. Due to its stability or inert nature, it will be used as cosmetic surgeries also because it will not react very easily. Hello everyone, this is Harshita Bhavasar from Vidhyaashram, PU College, Temple of Excellence. Today, I am going to start session 5 from the chapter Some P Block Elements. In the last session, we have discussed about physical and chemical properties of carbon and carbon family, anomalous behavior of carbon and allotropic forms of carbon. These are the contents or topics we have discussed in the previous session. In today's session, we will discuss about oxides of carbon and silica. Okay, these are the two topics which we will discuss in this session. So first we will see what are oxides of carbon, how it will form. Two important oxides of carbon known as carbon monoxide and carbon dioxide. First we will look upon carbon monoxide. In that preparation, oxidation of carbon with limited supply of oxygen or air gives carbon monoxide. When oxygen is added to carbon, that process will be called it as oxidation. It will form carbon monoxide. Another method, pure carbon monoxide is prepared by the dehydration of formic acid using concentrated H2SO4 at 373 Kelvin. Formic acid means HCOOH. Dehydration means removal of water molecule will form carbon monoxide and water molecule will be the removal part. Another method, carbon monoxide can also be obtained in the form of producer gas and water gas. A producer gas means it is a mixture of carbon monoxide and nitrogen. It is obtained by passing air through heated coke at 1273 Kelvin. There are three methods. First, oxidation of carbon. There is also formation of carbon monoxide. Next, dehydration of formic acid, where the water molecule will be eliminated or removed, then it will form carbon monoxide. The third method, carbon monoxide, can also be obtained in the form of producer gas and water gas. What is producer gas? It is a mixture of carbon monoxide and nitrogen. It is obtained by passing air through heated coke at 1273 Kelvin. Carbon, oxygen and nitrogen will form carbon monoxide and the removal of nitrogen. What do you mean by water gas? That is synthesis gas. It is a mixture of carbon monoxide and hydrogen. The gas is made by passing steam over a red hot carbon fuel such as coke. Carbon or coke in the water 473 to 1273 Kelvin, hydrogen and carbon monoxide will be formed. These are the three methods in which carbon monoxide can be prepared or synthesized. Properties of carbon monoxide. The physical properties of carbon monoxide are, it is a colorless, odorless, neutral, gaseous oxide which is highly poisonous. These are the physical properties of carbon monoxide and also sparingly soluble in water but completely soluble in ethanol and benzene. It has melting point around 199 degrees Celsius, boiling point 91.5 degrees Celsius, relative density 1.25. These are the physical properties, and chemical properties are, it is flammable and highly toxic gas. It is neutral oxide which burns in air to give carbon dioxide. Further oxidation will take place to form carbon dioxide, and for carbon monoxide it is a flammable and highly toxic gas. Carbon monoxide is a strong reducing agent and reduces metal oxides to metal. Carbon monoxide means in which the vehicles will, whatever the fumes are coming, that will be considered as carbon monoxide and it is highly flammable and toxic gas. For example, ferric oxide and carbon monoxide treating and it will gives iron plus carbon dioxide. Zinc oxide treating with carbon monoxide, it will form zinc and carbon dioxide. Means from metal oxides to metal it is converting. Next, poisonous nature of carbon monoxide. Carbon monoxide inhibits the blood's ability to carry oxygen to blood tissues, including vital organs such as heart and brain. What will carbon monoxide will do? It will inhibit the blood's ability to carry oxygen to the heart and brain. When carbon monoxide is inhaled, it combines with oxygen carrying hemoglobin of the blood to form carboxyhemoglobin. It reacting with hemoglobin, it will form carboxyhemoglobin. This complex is nearly 300 times more stable than hemoglobin. How much it is stable and why it is very toxic means 300 times more than hemoglobin stability. This prevents hemoglobin in the red blood corpuscles from carrying oxygen around in the body and ultimately resulting in death. Formation of carbonyls. Due to the presence of a lone pair of carbon monoxide molecule act as electron pair donor and reacts with certain metals when heated to form metal carbonyls. When it will form metal carbonyls or carbonyls, it is having a lone pair of electrons. So, it will be acting as electron pair donor. By that it will form metal carbonyls. Next, carbon dioxide. First we will see the preparation. Carbon dioxide can be obtained by complete combustion of carbon and carbon containing fuels in excess of air. When the fuel or carbon containing fuel gets completely combusted, then carbon dioxide will form. Carbon plus oxygen, carbon dioxide. When methane is burnt in air or in the presence of oxygen, carbon dioxide and water molecule will be seen. Next, laboratory method. In the laboratory method, carbon dioxide is prepared by the action of dilute HCl and calcium carbonate. Calcium carbonate is treating with hydrochloric acid. It will form calcium chloride, carbon dioxide and water. This is a laboratory method. Physical properties: colorless, odorless, tasteless, much denser than air, fairly soluble in water like carbon monoxide. Next, chemical properties: does not support combustion, that is, does not allow substance to burnt in it. Acidic to moist litmus, reacts with water forming carbonic acid, turns lime water milky. This is the classical test of carbon dioxide. This test will do in the qualitative analysis of inorganic salt, where that lime water will turns milky and it will shows the confirmation of presence of carbon dioxide. Next, influence of carbon dioxide on alkalinity. Carbon dioxide dissolves slightly in water to form a weak acid called carbonic acid. What they are telling? Carbon dioxide dissolves slightly in water to form carbonic acid. Whenever you are drinking aerated drinks like Pepsi, Coca-Cola, whatever it is, that aerated drinks, when you open that fizzy sound, fumes will come, that will be called it as carbonic acid. According to the following reaction, how it will form? Carbon dioxide plus water form H2CO3, that is carbonic acid. The low solubility of carbon dioxide in water makes it of immense biochemical and geochemical importance. Carbonic acid is a weak dibasic acid and dissociates into two steps. See here, carbonic acid reacting with water, bicarbonate and protonoic acid can be seen. This is bicarbonate with water, carbonate will form. Note, bicarbonate and or carbonate buffer system helps to maintain pH of blood between 7.26 to 7.42. Means it will maintain the pH of blood. Being acidic in nature, it combines with alkalis to form metal carbonates. Carbon dioxide completely acidic in nature, so that it will react with alkalis to form metal carbonates. Next, role of carbon dioxide in photosynthesis. Carbon dioxide is one of the most abundant gases, normally 0.03% by volume in the atmosphere. Carbon dioxide plays an important part in vital plant and animal processes such as photosynthesis and respiration. We know that photosynthesis needs carbon dioxide, by that only glucose will form, as well as for respiration also carbon dioxide is very much required. Green plants convert carbon dioxide and water into food compounds such as glucose and oxygen. This process is called photosynthesis. The reaction of photosynthesis is as follows: 6CO2 plus 6H2O in the presence of sunlight and chlorophyll, it will form C6H12O6. This is nothing but glucose and oxygen and water will be formed. This is overall photosynthesis reaction which you have studied in 10th. Plants and animals in turn convert the food compounds by combining it with oxygen to release energy for growth and other life activities. This is the respiration process, the reverse of photosynthesis. The reverse of photosynthesis will be respiration, in which the oxygen will be used to give carbon dioxide. The respiration reaction is as follows: this is glucose and oxygen which will be used in the respiration process and it will give carbon dioxide and water molecule. Photosynthesis and respiration play an important role in the carbon cycle and are at equilibrium with one another. Photosynthesis dominates during the warmer part of the year and respiration dominates during the colder part of the year. This photosynthesis and the respiration will play an important role in the carbon cycle. Because of that only we are and other plants and other animals are also living. Next, environmental problems. The greenhouse effect. The troposphere is the lower part of the atmosphere, about 10 to 15 kilometers thick. Within the troposphere there are gases called greenhouse gases. When sunlight reaches the earth, some of it converted to heat. Greenhouse gases absorb some of the heat and trap it near the earth's surface so that earth is warmed up. Means outside the earth about 10 to 15 kilometers sphere is thick, layer is formed, that will be called it as troposphere. Within the troposphere greenhouse gases will be present. When sunlight reaches the earth, it will penetrate through the troposphere so that earth will get warmed up. This is known as greenhouse effect. Life as we know exists only because of this natural greenhouse effect, because this process regulates the earth's temperature. This is normal greenhouse effect, in which heat also we need, light also, because of sunlight. If the greenhouse effect did not exist, the whole earth would be covered in ice. The amount of heat trapped in the troposphere determines the temperature on the earth. Whatever troposphere will trap the sunlight, that much temperature will be absorbed by the earth. That is not absorbed by the troposphere means our earth will be completely covered by ice. The amount of heat on concentration of atmospheric greenhouse gases and the time these gases remain in the troposphere depends in the atmosphere. The most important greenhouse gases are carbon dioxide, chlorofluorocarbons, nitrogen oxides and methane. Carbon dioxide can be obtained as a solid in the form of dry ice by allowing the liquefied carbon dioxide to expand rapidly. Carbon dioxide can also be get as a dry ice. Next, structure of carbon dioxide. In carbon dioxide, each carbon undergo sp hybridization because beside carbon double bond is present. The hybridized orbitals form 2 sigma bonds. Here 1 sigma, here 1 sigma. This is 1 pi, this is 1 pi. 2 sigma bonds will be present. The unhybridized p orbitals are involved in the formation of 2 pi bonds. The shape of molecule is linear, bond angle is 180 degree. The carbon and oxygen bond lengths are equal to 116.3 picometer. The net dipole moment is 0. In the unit 4 itself, we have studied that carbon monoxide doesn't show any dipole moment, means it will be equal to 0. That's why it is linear in structure and its bond angle is 180 degree. Next, uses of carbon dioxide, that is photosynthesis, manufacture of food by plants using light energy, fire extinguisher. Carbon dioxide does not support combustion and it is heavier than air. fizzy drinks, sparkling water and sparkling wine, great quantities of carbon dioxide can dissolve in water under pressure. Refrigeration, dry ice is solid carbon dioxide and is solid to keep items cold without wetting them. Dry ice turns directly into a gas on heating and it does not melt, forming a liquid. These are the 4 uses of carbon dioxide, mainly photosynthesis. Next, fire extinguisher. Next, this fizzy drinks, carbonated or aerated drinks. Next, in refrigeration. These are all in which daily life we can experience it. Next, silicon dioxide. Because we are studying in carbon family oxides, first we have elaborated the oxides of carbon. Next is silicon dioxide, which will be called as silica. Silica occurs commonly in nature as sandstone or silica or quartz. It is the starting material for the production of silicate glasses and ceramics. Ceramics means whatever the porcelains are you are using, or in the washrooms, whatever the white color ceramics you people have been seen, that is made by silica. Silica is one of the most abundant oxide materials in the earth crust. It can exist in the amorphous form or in the variety of crystalline form. It can be amorphous also, it can be variety of crystalline also. There are 3 crystalline forms of silica, that is quartz, tridymite, cristobalite, and there are 2 varieties of each of these, high and low. Between high and low, in this 3 crystalline only they are formed. High purity grade silica, fused silica, is produced by carbon arc, plasma arc, gas fired continual extrusion or carbon electrode fusion. High purity will be formed like this. Fused silica is primarily used in the electronics industry, where it is good dielectric and insulating properties are exploited, though it may also be used as a refractory material or in the investmenting casting. Okay, where this silica will be much used. Silica has 3-dimensional network structure in which each silicon is bonded to 4 oxygen atoms were tetrahedrally disposed around silicon atom. See here, one silicon will be attached with 4 oxygen where it will form tetrahedrally formed. Each oxygen atom is shared by 2 silicon atoms. It may be noted that CO2 is a gas while SiO2 is a hard solid with a very high and melting point. This one oxygen will be shared with 2 silicon. That's why there is a variety of properties in carbon and silicon. Carbon dioxide is completely gaseous in nature, whereas silicon dioxide is completely hard solid and it is having very high melting point. Next, reaction with NaOH, that is sodium hydroxide. Silicon dioxide dissolves in sodium hydroxide solution to form sodium silicate. See here, when silicon dioxide will treated with a base called sodium hydroxide, it will form sodium silicate and water molecule. When reacted with hydrogen fluoride, what will form? Silicon fluoride will form. Therefore, HF cannot be stored in glass bottles which contain silica. Okay, because of this silica, they cannot stored in glass bottles. Uses of silica, it is used in large amount of form mortar, which is a building material. It is also used in the manufacture of glass and lenses. Silica gel is used as drying agent. Amorphous silica is used in filtration plants and chromatography. Okay, in the building of industries or any buildings, large buildings, and also the ceramics what I told, which will be used in washrooms or tiles, anything, floor tiles like that, drying agent, and also amorphous silica will be used in laboratories for the filtration purpose as well as the chromatography purpose. Next, silicones. Polymeric organosilicon compounds containing silicon oxygen and silicon bonds are called silicones. They have general formula R2SiO, where R is CH3 group, that is methyl group. or alkyl substituted Cl, aryl also can be formed. The partial structure of silicons is this one, R2SiO. Okay. Next, preparation of silicons. The preparation of silicons is generally carried out by the hydrolysis of or diaryl dichlorosilanes, which are prepared by passing vapors of RCl or aryl Cl over silicon at 570 Kelvin with copper as a catalyst. See here, RCl or alkyl chloride with silicon in the presence of copper as a catalyst at 570 degree Kelvin, it will form R2SiCl2, means dialkyl dichlorosilanes will form. When it is treated with water, silicones will form. This is how the silicones will be manufactured or prepared. The chain length can be controlled by adding CH3 or alkyl trialkyl silicon. Silicones may be obtained in the form of oils, rubbers or resins depending upon the extent of polymerization, which depends upon reaction conditions and nature of alkyl group. By adding alkyl group, silicones can be extended in the lengthwise and it will be present in the form of oil, rubber or resins. Properties of silicones. Silicones are water repellent and quite inert chemically. It will be water repellent because it will be found as oil. These resist oxidation, thermal decomposition and attack by organic reagents. Okay, it is very much stabilized. It will resist oxidation, thermal decomposition and attack by organic reagent. These are also good electrical insulators and anti-foaming agents. It will not form any foam. Next, uses of silicones. Silicones have been used for making waterproof papers, wool, textiles, wood, etc. After coating these articles with silicones. The wood, whatever the papers or wool textiles industries, they want to manufacture the waterproof things, they will coat with silicones, which is a water repellent properties containing. The viscosity of silicones do not change with changes in temperature. Therefore, these are used as weather lubricants. With the weather, it will not change of its viscosity. As anti-foaming agent in industrial process, as a mold releasing agent in rubber industry and foundry, it avoids the sticking of the castings to the mold, which will be used as molds also. For making body implants in cosmetic surgery due to its inert nature. Due to its stability or inert nature, it will be used as cosmetic surgeries also because it will not react very easily. Silicones are now incorporated in paints for resisting dampness and for water proofing. Due to their water repellent nature and high dielectric constant, silicones are used in electrical condensers also. Next, silicates. A salt in which the anion containing both silicon and oxygen, especially SiO4 2- ion called silicate. Anion containing both silicon and oxygen. The basic unit of silicate is SiO4 4-. The main structural unit of silicate is a tetrahedral cluster containing 1 silicon atom and 4 oxygen atoms. There will be presence of anion compulsorily with silicon and oxygen. Okay. With Si and silicon and oxygen bond length varied from 0.161 to 0.164 nanometer at ambient conditions. The strength of silicon and oxygen bonds is pretty high and dissociation energy is 452 kilojoule per mole. And it is thermal stability, chemically resistance, majority of silicate compounds. It is also having high resistance to chemicals and high resistivity with physical properties. Tetrahedral clusters can be polymerized. This is the structure of silicate, which is tetrahedrally formed. Okay. Next, zeolites. Zeolites are hydrated aluminosilicate minerals with an open structure which can accommodate a wide variety of positive ions like sodium plus, potassium plus, calcium plus, 2+ and magnesium 2+ and others. The general formula Mx or N, aluminium dioxide X. You see here silicon dioxide with Y and M hydrate, where M may be simple cation like sodium, potassium or calcium. N can be the charge on the simple cation. M is the number of molecules of water of crystallization. More than 150 types of zeolites have been synthesized. There are 48 known naturally occurring zeolites. Aluminosilicate. Uses of zeolites. Zeolites are widely used as catalyst in the petrochemical industries for cracking hydrocarbons and isomerization. Isomerization, hydrocarbons preparation or the cracking of hydrocarbons, there will be zeolites will be much used as a catalyst. See here ZSM5, a type of zeolite used to convert alcohols directly into gasoline, which is a petrochemical byproduct. Hydrated zeolites are used as ion exchangers in softening of hard water. In the water purifiers, the zeolites will be present to ion exchange. Clinopteolite, a naturally occurring zeolite, is used in soil treatment in agriculture. It is used as molecular sieve for extracting oxygen from air in the process which involves adsorption of atmospheric nitrogen. Usually this zeolites naturally or artificially made zeolites will be used in water treatment, soil treatment or oxygen absorption treatments. Zeolites can also be used for solar thermal collectors and for adsorption or refrigeration. Synthetic zeolite is widely used for the global laundry detergent. You have seen silicates, silicones and zeolites with silicon dioxides, the oxides of silicon, as well as you have seen the carbon dioxide and carbon monoxide, oxides of carbon, its preparation as well as its application level. Okay, I hope you have understood completely all sessions from this chapter. The Some P block elements chapter has been completed. We'll meet in the next chapter with a fresh, newly started chapter. Thank you.